Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Today we'll discuss the concept of continuity. A friendly definition of continuity is that a function is continuous if you can sketch it without picking up your pencil. It can be drawn as a continuous curve. More precisely, a function f is continuous at a number a if the limit as x goes to a of f of x is equal to f of a. What that means is that as you come in toward x equal a from the left, and from the right you get the same value, and the function itself has that same value. So the limit exists and the function value exists, and those match up. So thereby we get the conditions for continuity, that the limit as x approaches a of f of x must exist, that is, the curve must come in from both sides toward the same y value, and the function must be defined at a, and the third condition is that that limit and the definition of the function must have the same value at x equal a. There are three types of discontinuities that we'll discuss. First, we'll discuss removable discontinuities. That's where there's a hole in the curve. In this graph, we have a hole at x equal -1, y equals 1. The curve would be continuous at x equal -1, except that there's a hole. And if we redefine the function such that that hole were filled by defining y of -1 equals 1, then the function would be continuous at x equal -1. There are also infinite discontinuities. At an infinite discontinuity, the function approaches infinity, either plus infinity or minus infinity, as x goes toward a particular value. And finally, we have the jump discontinuity, and we have several in this figure. Here's one of them at x equals 0. The y value jumps from 1 down to 0. Again, at x equal 1, the function jumps from y equals 1 to y equals 0. Let's discuss some properties of continuous functions. If we have two continuous functions, we can add them, we can subtract them, we can multiply them by a constant, and we can take the quotient of them as long as the denominator does not equal 0, and the resulting functions will also be continuous. From this concept, we find that polynomials are continuous everywhere. Rational functions, roots, trigonometric functions, exponential functions, logarithmic functions, they're all continuous wherever they're defined. And finally, compositions of continuous functions are continuous. So if f is continuous and g is continuous, then f of g will also be continuous at the appropriate points. We also discuss the intermediate value theorem because that is related to continuity. That if you have a function that's continuous on an interval from a to b, then since we can draw the function without picking up our pencil, the function must actually attain any y values between y of a and y of b. For example, if y equals d is between f of a and f of b, the function must at some point between a and b attain the value of d. And we have that over here. The value might be obtained more than once. Back in the late 1950s, the space race was going on, and three of the people doing research for spacecraft were doing their research at MIT. They were focusing on the computers that were to be used on the space capsules. One day, a professor that all three of these engineers knew fairly well stopped by. The professor, also an engineer, had previously shown only passing interest in the work that these professors working on the space project were doing. This day, however, the professor spent about half an hour with one of the professors, all asking all sorts of questions about what he was working on. Afterwards, the professor went to the two other engineering professors and spent time with each of them, asking similar detailed questions. As the other professor left, the three professors, the three engineers working on the space race, got together and discussed this strange visit because this other professor had never shown any interest in their work. Well, it didn't take them long to realize that the professor was going to give a lecture on the research that these three engineers had been working on. And it took even less time to discover which class this lecture was intended for. Determined to spice up the lecture, as friendly engineers might do, they dropped everything and ran over to the lecture hall where the class was about to start. They got to the class and sat down in the back before the professor arrived. They were determined to ask him all sorts of questions that he couldn't possibly answer about their own research. Well, when the professor walked in, he stopped for an instant after noticing the three engineering researchers sitting in the back. He walked up to the podium and immediately began his lecture. Ladies and gentlemen, I promised you that today I would bring you all up to date on the latest developments in our research involving putting a man in space. Well, I'm pleased to announce that I've done even better than that. Today I have with me the 3 engineers who are heading the project, and they will each be speaking for 20 minutes on their respective areas of focus. Thank you for joining us today. Have a great day, and may the power of math be with you.